For 14.8 types of organic reaction, probably the last topic for this chapter. This is just a heads up. This is just know-how for the basics of organic reactions that you might come across with in upcoming chapters from all the way from 14 to 18. But really, there are no more details here. So if you get stuck with any of these, and if you think that you don't completely understand it, don't worry. With every kind of reaction, what you'd notice is a specific section dedicated to it. For example, 15.3 is dedicated for this one, 17.3 for this one, chapter 18 for this one, so on and so forth. You would find this kind of detail with every portion of organic chemistry. So if you don't understand it over here, no problem, don't worry. Wait for that specific section that it is referred to, and we'll understand it over there. Since these are just two-line explanation for this one, the proper final details would be found over there. So let's move on. Addition reactions. Since you are already familiar with addition reactions, so I'm going to quote a couple of examples apart from the one that is already over here. Formation of a single product, two or more reactant molecules, and usually if one of them contains a double bond or maybe a triple bond. That's how it works. For example, you have seen halogens being added to alkenes in such a way that they form a single product. Now, if you remember, it was done back in IGCSE in this way, that it's an alkene, and what we usually do is that we break one of its bonds and added another set of bonds over here. And since the molecule being added can be divided into half, maybe an equal half, maybe unequal half, so we can add it over here. In case of bromine, there was another kind of reaction back in IGCSE. So I'm going to explain all three of the types that we did back in IGCSE. So the second type was this one, and here we added hydrogen to it. This specific reaction converted alkenes into alkanes. Moving forward, another type. And for this one, we used to add water. So H on one side, OH on the other. This was used to convert alkenes into alcohol. This was considered as hydration. And we did hydration of ethene specifically back in IGCSE. This was known as hydrogenation. We used hydrogenation to convert vegetable ghee into, or vegetable oil into margarine. And this was known as halogenation. And we studied all three of them back in IGCSE. So we are pretty familiar with addition reactions. What we're going to do over here is going to be a step up. We're going to study further depth of what we were already doing back in IGCSE. So I hope this isn't difficult for you. Moving on. Elimination reaction. As the name suggests, we're going to remove a small stable molecule from a larger reactant molecule. An example of this is dehydration of alcohol, since it has been taken out of O-levels course, but I guess this is still a part of our IGCSE's course. So you already know that hydration of alkene produced an alcohol, and an alcohol can undergo an elimination reaction with the help of a dehydrating agent, which can take out water and convert that alcohol back into an alkene. Now, what that was supposed to do was something like this. If a structure like this, since the same example has been quoted over here for ethanol, can be converted back into ethene. So entire molecule was taken out of it, and it was then converted back into an alkene. Water was taken out of it. Though this was considered back then as a dehydration reaction, right? But now we are going to actually study its organic type that we refer to, and that is elimination reaction. Back in IGCSE, no name like elimination reaction was present. We only used to call it dehydration reaction. So that's the difference between IGCSE and here. And here we're going to obviously study more detail. Let's move on. Next up is condensation reaction. Now, condensation reactions involve a first step where addition takes place, then it is followed by a second step where elimination occurs to form the final product. So it's also known as addition-elimination reaction, but we usually call them condensation reaction. Condensation reactions were discussed in the polymers chapter, where you discuss condensation polymerization. Now, it wasn't discussed specifically for other organic homologous series, but we're going to discuss it over here for carbonyl compounds. The new homologous series we are supposed to study in A levels. So let's not discuss this one in detail, since you definitely require some prerequisite knowledge to the new homologous series before we get started with the further details of condensation reaction. Let's move on. Then we have substitution reactions. Now, a kind of substitution reaction, though substitution is a bigger, broader category, and it actually involves many kinds of reactions, but one kind of substitution reactions in which an atom or a group of atoms are replaced by another atom or group of atoms. There are many possibilities. We actually understood the free radical substitution, and you never know it was a free radical substitution back in IGCSE. It was a simple photochemical reaction of alkanes with chlorine in the presence of sunlight or UV light. We studied this reaction, actually a series of all four reactions back in IGCSE, in which every time an H atom replaced by a halogen atom in methane or alkanes, since the exact example was methane back in IGCSE, so we used to do that. However, the past paper do quote some examples of ethane, propane, or butane. That's as high as they go. Now, we are going to study this detail. Some of this detail has already been catered. I hope you remember that free radical reactions have been discussed previously, and we have already explained to you the three steps of how free radical reaction usually go. We have told you there is an initiation reaction in which we usually produce a reactive free radical, which is then capable to go on with a propagation reaction. And propagation reaction is like a series of chain reaction which goes on and on and on until unless the radicals actually react among themselves to produce a molecule, which we usually call a termination step. So since there were three steps to this one, we already know that how this is going to happen. Okay, but that's not just what substitution is all about. As I just told you, substitution is actually a bigger, broader category. So we may have some other kinds of substitutions in upcoming chapters, and a couple of those are discussed over here. Hydrolysis is the breakdown of a molecule by water. You can speed up this kind of reaction by adding either an acid or an alkali. For example, hydrolysis of a halogenoalkane, in which we need to take the halogen out and replace it with, let's say, an alkali like this, is also kind of a substitution reaction. Hydrolysis with alkali is actually faster. Take a look. With water, it's a little bit slower. With alkali, it's actually faster and better. But it gives slightly different products that we're going to discuss in detail very soon in chapter number 16. So this is another kind of substitution. We're going to study in detail what kind of substitution this is and what are the requirements for this one. Moving on, oxidation reaction reactions are the ones that occur in the organic chemistry as well as in inorganic chemistry. So we're going to discuss the same over here. So oxidation is defined as loss of electrons from a species. However, when we're going to talk about organic reactions, it is often simpler to think of oxidation reaction in terms of oxygen or hydrogen before and after a reaction. So, for example, oxidation of ethanol to ethanol or to ethanoic acid using a strong oxidizing agent such as this one, acidified potassium dichromate 6, acidified potassium manganate 7 solutions is very easy. You would notice that we are actually adding oxygen or removing hydrogen in order to be able to say that this was an oxidation reaction. So take a look at this. If you look at this, you would understand that we are reacting it with oxygen. Maybe we're not adding a number of oxygen atoms, but we're definitely taking some hydrogen out. So whether it's the addition of oxygen or whether it's the removal of hydrogen, we know we categorize both under oxidation reaction. So they have actually counted the oxygen and hydrogen atoms for your understanding's sake, right? And we can safely say ethanol has been oxidized. Well, there are, of course, steps to understand how these kind of reactions goes. And with those steps, we're going to make it easier for you. But I always say it's better to go with organic in terms of systematic because organic is very systematic. You would understand everything behaves in a manner. So if you understand those systematics, it would be easier for you to study organics rather than just going with a few tips that might get you with some marks, but that can never actually make you a pro at organic chemistry. All right, so notice that we use simply atomic oxygen, oxygen brackets, and chemical equations to describe oxidation reactions. They're commonly used. The equation must still be balanced like a normal equation, but that is actually done for the ease of students. Since if we write normal equations, we might have to add a few more real products to the whole equation, right? There are other examples to this one. Since I was saying ethanol can be converted into ethanol or ethanoic acid, the conversion to ethanoic acid is given over here. This is something, this specific reaction is something which you have studied back in IGCSE. It was not a part of O levels, but it definitely was a part of IGCSE, though some O level books do contain the equation. So vice versa, reduction, an example of ketone is given. A very strong reducing agent has been discussed, sodium tetrahydroborate, NaBH4, which actually provides hydrogen atoms to the system, and adding more hydrogen to the system or taking some oxygen out are both categorized in the reduction reaction. So I hope you do understand that oxidation and reduction are both going to be a part of organic chemistry as well. And this actually completes the topic.